next speaker, Alexey Borisenko, is a DevNet developer at Cisco with a background in app and infra development with 7 years of experience creating application, web services, and networking solutions. Alex has been in many different roles, from working in startups, small companies, and now creates and helps integrate third-party applications with Cisco's products and solutions. His sphere of interests include network programmability, IoT, data science, and education technologies. And outside of work, he is very passionate about triathlons, and one day we'll hope to complete the Ironman in Hawaii.
I hope so.
Yeah. So, speaking today on creating IoT solutions using LoRaWAN Network Servers, please welcome Alexey.
Thank you, Trevor. Thank you, guys. I love to see you. I have some speak with each of you, and it was a beautiful auditorium here. I want to present you a speech about creating an IoT solutions using LoRaWAN service. Can you raise a hand who have heard about LoRaWAN? Oh, good. Hope you enjoy this presentation also. And for new one, those things that I will talk about are also relevant for others low power technologies like Sigfox, narrowband IT, so you can scale it, this experience. We in Cisco have some program for developers that called LearnNet, and inside this we help our clients to create third-party applications and some solutions that can extend the basic capabilities of our product and solutions. And some use cases that I show in my own experience with IoT, that we really run a few IoT projects in my country. What's the agenda of today? We are talking about technologies for the district and city level, because in IoT we have, for example, you want to create smart home solutions here. You can also use for this issue LoRaWAN. I said in my presentation how you can take it, but mostly low power technologies is using for district and city level, for smart cities, for smart countries, and etc. Second one is I tell you the type of sensors, what the specifics of these sensors, how and where you can buy it, and how you can program it. We talk about LoRaWAN gateways, this station we're collecting and can interact with end devices. We're talking about manufacturing types and deployment process of it. Then we talk about network servers. It's a solution that can collect data from LoRa gateways and interact with your application. We have paid variant, we have open source variant, so you can choose. If you want to run some startups, also it's good to know this information. And the last one, we talk about IoT applications that you can buy and develop around this. Can you raise your hand who use wired mouse? And how many of you are gamers? The same people. Okay. We have same situation in IoT. 10 years ago, mostly we use wired technologies in IoT. All sensors connected by wired. Now everything is moving. For example, for room level, for apartment level, mostly we use, for example, Wi-Fi, ZigBee protocol. For district and city level, we use narrowband LTE that's based on, for example, 4G network, 5G network. LoRa, also Sigfox, is a little bit competitor in this. Okay, why LoRa? Here you can see a table where we compare different technologies. You can see this also Sigfox, narrowband LTE. Each of these have a different speed, have different security issues and energy use. And as you see, For example, some of these don't use so strong security, and you can see energy use is very important for end devices. For example, how many energy do you need to change battery each day, each hour, for example, or you need constant power for it. It's important for devices, for example, when you give it on big building, you can change battery, for example, each month. And it's very important, and you see this first three, it's very low using battery. The end devices can be working without change battery, for example, 3-4 years. Some devices is 5 years. It's very good, and we talk on some use cases how we can use it in our product. Also, these technologies you can jammer. Do you heard about Wi-Fi's 4G or GPS jammer? Yeah, you heard about it. Some technologies, for example, can be jammered by these devices. For LoRa, there is no jammer, and it's good news for those who want to build their solution around this. Also, radio location, for example, some military company using LoRa in, for example, monitoring military vehicle, for example, how many fuel there, how many some resources there, and it's important that other people can ping where you on the map, for example. LoRa is very hard to ping and to find you where is your location, and it is good also for military, but not only. And LoRa and some of other low power solutions have very high penetration power. For example, if you have some sensors on the manufacturing, for example, that inside constrained structures, it will be work, for example, but it's not relevant for 4G, for example, in some cases. The second one, LoRa have a big radius. In a city, we have like 10-12 kilometers, so you can put one station and cover one district, for example, in big city. Outside the state, we have outside the city, we have the project. For example, in agriculture, there is up to 15-17 kilometers radius. The good news for you is that all of you can buy this LoRaWAN gateway, put it, for example, on your building, and you don't need the license for it or any permit is required. The LoRa is unlicensed frequency band. It uses 866, 68 megahertz. Scalability. One gateway can interact, it's up to 20,000 per one gateway sensors. So it's very expensive to maintain it. And low cost, both radio gateways and devices. I showed you, you also have in Romania some companies that make smart light solutions. Yeah, it is very well known, and we in Ukraine also use it. Due to its low power consumption, sensors run an average of 5 years, as I said before. The last one, but very important, is data security. All data is encrypted, and each sensor has its unique encryption keys. I showed you in one of the slides that for each case you can generate application security key, network security key. So maybe you heard about some hackers or attackers who can attack, for example, smart home and get access to camera, to turn off, turn on light. Do you see this video on internet? Yes? So, no. It's very important to protect the data in IoT, and LoRa and others low power technologies have encryptions, and it's very important. About ZigBee and Wi-Fi, for example, if you use it for your home, there is a big interference between it. For example, when we use low power technologies, you can use more sensors per one devices, and there are no so big issues when you use LoRa, for example, that connected with interference. Let's compare SIG4 and LoRaWAN. Are they still competitors? Yes, they're competitors, but for different projects you can use different technologies, and most of you are developers. I said about some technology differentiation between, but you mostly must concentrate on your end product. It's very important for your IoT technologies. It's very scalable, so if you know about LoRa, you can easily change to Sigfox and to other technologies. Okay, so the advantages is spectrum, spirit spectrum. You can use high payloads. Payloads is up to 255 bytes. In Sigfox is only 12 bytes, but as we see next, 12 bytes you can really input there very useful information for sensors. It's a map of France, of LoRa coverage in France. Here is a map of Ukraine, where I'm originally from. We have IoT Ukraine is our company, first Ukrainian national operator of LoRaWAN, and they cover the biggest city in Ukraine. So we started to improve these technologies. As I know, in Romania you have also some projects connected with low power technologies. How LoRa is worked? You have some sensors here. You have LoRaWAN stations that get signal, and you have LoRaWAN Network Server. Then you can get information from this server, collect it, analyze it. This is what is your developers and managers work, how to combine it, what to work, how to present it. Also, you can see that data is encrypted always. For each devices, we generate network security key and application security key. The useful information is in payload. Each device has that information in network, also encoded by application security key. And in this payload, we store sensitive data. Talking a little bit about LoRa sensors and smart devices, you can see also two links. First is Alcoep, is one of the manufacturers that provide different type of sensors, and second one is Flash Lighting, is a Romanian company that creates smart lighting solutions. Each smart devices have different parameters to manage that you can also manage. First is sleep time. It's time that devices are in sleeping, and then the devices can detect, for example, some data. If you're talking about parking sensors, they wake up, check are there any vehicle on it, and if no, they go to sleep time, to another sleep time cycle, or send some information to our LoRa networks. Also, each, for example, hour, each 2 hours, each 4 hours, it's up to how you program it. Device can keep alive, that always log some information about battery, about his other conditions. And also, you can go devices in night mode. For example, when you use device in offices, some devices that analyzing, for example, environment, and you know that there is no people in the office till the night. You can modulate this night mode, and device for this time go for deep sleep for a couple of hours and then wake up. That is why devices also can work more than 4 years. And also each day we have one frame, one packet that is responsible for RTC update request that is synchronizing with network server by time. So you can see here timeline. For example, we have sleep time 7 minutes. So slots are occupied, some changes, then wake up on this and send information to our network server. So you should need to understand about 3 parameters. First, sleep time, keep time alive, night mode. It's very important for manage your end devices. There is an example of LoRa sensors. We have, for example, water detector, fluid sensors, smoke sensors, sensors open and closing door. Each devices have a unique ID that you also need to put in your network server to identify it. Also, you can see motion sensors. So, as I said to you before, you can use LoRa devices in your on your home level for your application. When you work with IoT, you don't need only. It's not enough to sitting and coding your application. Sometimes you need to go outside, have some deals with your outdoor sensors, construct it, reprogram it, and other. Here you can see some program that you can upload data for your sensors, for your end sensors. As you can see here, we have unique data for network session key, application session key, device ID, device address. You can also manage night mode, as I said you before, for example, night mode 6 hours or 8 hours, and time, sleep time. You can manage it for each devices. You have program like this, so you can manage these parameters when you program it. Interaction with sensors. We have 2 parameters: uplink, when sensors send information to our network servers, and downlink. Here you can see 12 bytes. It's 96 bits. It isn't enough. Here we see example of payload. And for these parameters, we can get, for example, timestamp, frame time, parking slot is for parking solution, battery, recalibration, and also more than 20 parameters that you see here. I mean that 12 bytes, it's really big for sensors, and you can also include all information that you need. How can you interact with end devices? You can not only bring information, but for example, you can downlink message, send downlink message to your end devices. For example, for water matter. If you see that people use water, for example, and don't pay your organization, you can block it. In using your network server, you can write some API. For example, in my case, it was activity, and there is a link of how you can send the API request to send message to your end devices, so you can interact. You not only can collect information, but you can manage it. So it's very important for your IoT application. Here is a sample of uplink the device sent you to your application. So it's nothing complicated. As I heard on previous speech, you don't need to program. You just only need some language that can help you to parse and then manage these devices, show some information to end consumer, create some analytics of this, this is what the programmers can do in IoT application. Okay, what interaction we also has with sensors. Here is a sample of uplink that can send environment sensors that can analyze environment. You can see 12 bytes here and how we can parse this metadata. Here is a GIF of Transfer Garage. Yeah, it's in good quality. It's around 7 megabytes. So to send it, we need like a couple of seconds. But this 7 megabytes, for example, of LoRa data, we can send it and work by using this traffic for 3 years and 4 days. So 7 megabytes for each device is 3 years and 4 days data. For example, each day devices send each hour some uplink. It take maximum 255 bytes. For example, each 2 hours they send keep alive, and 1 day FTC. And it's enough for now for getting some information for one device. So 7 megabytes in the LoRaWAN networks is very huge information. It is enough to collaborate with end devices for 3 years. As I said in agenda, we can talk a little bit about network servers. I share with you some link to open source network servers that you can run in your cloud, in your private cloud, that also can do these things for you. LoRa processor, WebSocket connector, MQTT connector, store some database, REST API. Also, you can manage some HTTP connection here. In production, what we use, we have some collaboration with Utilities companies that provide paid network servers. You can see screen when you can manage base station, you can manage devices there. Here is a screen when you can add information about your LoRa gateway. Let's talk about IoT applications. There is a photo of the art mall in Kyiv shopping center, and he's changed old smart light solution to a new one with LoRa, and have economized 31 kilowatts per day or 11 megawatts annually. It's like 60 less than before reconstructions, and projects that connected with smart lighting, it's really give a big economy to company, to your end customers. So in these solutions, they have some diagnostics, for example, which lamp is shut down, have some problem, have automatically calendar dining. For example, when it's night, it's nobody on parking, you can manage it by clicking some interface in your graphical user interface. The second example is connected with gas matter, water matter. As I said to you before, you can create solutions that can active monitoring data. You also can have some intelligent user interface for this. You can reduce property damage. It's in some countries very important. Early detection of water or gas leaks. You can send push notification to a special organization about this. And data analytics. I know a couple of speech about this connected with AI. In IoT, AI is very important. You can predict some things. You collect this data, analyze it, and predicting, forecasting some things. It's also very important. Third one is connecting with collecting trash, monitoring trash over time. Also collect some statistic data, how many trash overturned, and garbage collections. These solutions costs reduced to 70%. It's how you can go to your end customers and show, because IoT, you see, you have some costs on devices, on gateways, on creating solutions. When end customers, when company can economize money, you can show it really use cases when these applications, these IoT solutions can help to monitor, to collect and to manage their business. You can see here gifts of solutions that I developed, connecting with parking solutions. We log in it. We don't only collect information about which places is busy, which occupied, which is free. We create solutions that you can, in close parking, book your, for example, you have some customers that come to your office in 2 days. You can book some place for data. You can choose time period for it. So administrator also can see how many free parking slots they have, manage it, collect the data, how many bookings you have, how you manage it. For some cases, for big parkings, it was useful because you can mostly manage end devices, and it's good to give some money from customers. And a little recommendation for you, for those who want to start but don't know how, you can write me. On the next slide, you can see my email on the last slide. And I send you a link when you can subscribe on WebSockets and be receiving the data from this IoT solution to your server, so you can see how often this data comes. You can parse it, you can write your own solutions, and it's good because I know that there is no data in the internet how you can simulate it, and there is for real project we can give you some endpoint and send you notification. You can practice for those who want. Okay, we have no time. Here you can see special link. When you register there, you will be redirected to some labs and to some sandbox when you can practice your IoT skills, like intro to IoT technologies, protocols, tools, and others. To use some applications, application deployment, CI/CD process, you can practice all things that included in IoT. There is also, I leave my contact for those who want to practice. I sent you some useful information. So now I thank you, and I'm ready to answer your questions if you have.
Hi, thank you for your speech. So LoRa is easily received. You only use the gateway to participate in the network, and the only limitation I'm aware of is the duty cycle. What do you think will happen in the future with the spectrum as more and more IoT members will come up and join the network in all hacker spaces, different people, maybe bad actors?
For now, it's free specters. But yes, as you said, if we have more LoRa base station for 1 kilometer, it will have some interference. But as I showed you before, for each devices we have special parameters that you can see that this data is from your devices and is encoded by your network security key and application security key. For now, LoRa is absolutely free. And for example, here, if you open Wi-Fi networks here, we have great interference in Wi-Fi and ZigBee. In LoRa, there is no network for now, and it big advantages for our technologies. for now. Yeah, thank you.
Can you talk? Thanks. Can you talk some more? You mentioned briefly this problem of people turning on phones, and obviously a phone is an extremely well-defended device that most people keep more or less up to date. The security of the Internet of Things, has there been a shift of recommendations about that? I personally don't understand why we don't expect there to be hubs providing the security and then all the other things coming off the hubs. I don't understand the direct connection onto the Internet for cheap products that people aren't going to upgrade.
Yeah, you're talking about some open source solutions that have issue connected with security.
No. Just basically for products. When people, why do you need an Internet of Things fork or light bulb or whatever? But people are creating these things, and then they're creating security holes, right? So are there recommendations about does this?
Yeah, recommendations. Low power technologies, as I said to you, have some basic protocol requirements about network security key, application security key, encoded signal from end devices to a network server. So from the scratch, they have very powerful security on this, and also you can out down some security like HTTPS protocol in your IoT application, for example, or encoded your IoT data for end customers.